guys, it's Rolly, and today I'm going to show you guys a really cool rainbow themed experiment that you can do with your Skittles, and it will be sure to wow your friends, your family, your pets, anyone you want to show. So really simple, really fun, and let's dive in. I'm going to go over what you need for this experiment. All you're going to need is some Skittles, which you guys all have in your Kesem at home packages. And you don't need this many. I only bought this many for myself because I'm going to be eating all of these after the experiment. And you also will be needing a plate, any size, preferably a lighter color so you can see the colors better. It'll make sense once you see it. But yeah, any plate. Some boiling water. I boiled my water in a water boiler, but you can use a, heat it up on the stove or heat it up in the microwave, whatever you have. If you don't have one of these, just like any hot water, like if your tap comes out really hot, use that. And then what I'm gonna do is also just pour the hot water into this bottle. That'd be easier for me to pour precisely onto the plate because I'm not confident in my pouring skills. If you guys are, go ahead and pour straight from the thing. Quick safety note about boiling water. When this thing ends boiling, it is scalding hot, so make sure you have your guardian around to help you with the boiling water. So the first thing I'm gonna do is open up my Skittles bag. I need some energy. Okay, now I'm ready to get going. So what I'm gonna do with these is organize them into a rainbow pattern just so it looks really cool. Do it how you want it, choose your favorite colors, get really creative with this part. Eat some Skittles on the way, you know. Alright, now that I have my Skittles the way I want them, I did them in a classic Roy G. Biv rainbow, red, orange, yellow, green, purple, but you can do any color pattern you want to your heart's content, do it randomly, it's gonna look cool either way. So the next step is to get your hot water just a little bit, a little bit cooler than it would have been if it was boiling. That's why I let this cool while I was setting up my Skittles. And now the moment you guys have been waiting for, time for rainbow Skittles soup. So what I'm gonna do here is take my rainbow setup and my little jug of barely not boiling water, like just finished boiling, cool down a little bit, and take this and pour it directly into the center of the plate. And now we wait. I don't know about you guys, but this looks insane to me. And I'm kind of wondering, what happened to make the Skittles look like that? So let's talk about it. What happened to our Skittles when we put the hot water in them? Why did all the colors flow in like uniform lines? What happened? So the hot water is, creates enough thermal, meaning heat energy, to dissolve the sugar and the food coloring that surrounds the Skittles. And when that dissolves, it kind of comes off the sides of the Skittles and melts into the water. But actually, the sugar water that, the water that has the color and sugar dissolved into it from the Skittles is a lot denser than the regular water that you poured on the plate. Density means more of it in a smaller volume. Like, for example, my hand is not very dense now because it's spread out, but this would be a denser hand, more hand in a smaller volume. The denser sugar water is gonna go underneath the regular water. And the reason it goes in towards the center of the plate is because of the plate is like, you know, a little bit curved, so it goes down with gravity. So in this case, diffusion, what we saw with the sugar water going towards the center, and gravity work together to make a really cool trick in this demo, and it's really easy. So now it's your turn. If you want to try this out, grab a couple Skittles from your Kesem at Home kit, grab some boiling water and a clean plate, and just get to it. And I would love to see your guys' photos of all your beautiful Skittle Rainbow soups. You can also try it with M&Ms. Would love to see your guys' experiments, and thanks for watching. Bye! Welcome back to Kesem at Home Science Broadcast. I'm Rolly, and today I'm going to be showing you guys one of my favorite things to do with just 2 ingredients, cornstarch and water. I used to do this all the time growing up. It's one of the craziest, mind-boggling experiments you can do with like just 2 things. So let's get started. So what I'm going to be showing y'all today is how to make a weird textured ooze out of just cornstarch and water that has really weird properties when you touch it that is like nothing else you've touched before. So I'm really excited to show you guys. So what I have to use today is a paper bag just to put below the experiment to catch any fallout mess. Some cornstarch. I actually had this left over from baking. You might have it. If not, you can find it at like a pharmacy, a grocery store, anything like that. A jug of water, any temperature is fine, and a small bowl. Okay, so the first thing I'm gonna do is take my paper bag. You can use just anything that basically is going to protect your surface from the cornstarch mixture. Okay, so the next step is to take your cornstarch and pour just a little bit. If you want to measure it out, you can put maybe 1/2 to 3/4 of a cup. You can have your guardian help you find a measuring cup, but really it doesn't have to be precise. So now what I'm going to do is I'm going to take my water and just start pouring it into the cornstarch directly. And you can use like a spoon, but I'm just going to use my finger to start mixing it up until you kind of feel that all of the powder is wet. And you might actually, I'm already starting to feel, you know, how weird it is. Not really mixing very easily, not mixing like you would expect something to mix powder and water. Oh, and that's why we have the paper bag down. As you can see, this experiment can get a little bit messy. So now I've added enough water to the point where the ooze, when I move my fingers very slowly through it, feels like it is a liquid. And that's the fun thing that we're gonna play with during this video is it a liquid? Is it a solid? You know, what's happening with this cornstarch and water mixture? So the first thing I'm gonna show you guys is just how weird the texture of this is. So you can pick it up and then it's on your hands, but then it oozes off very slowly. So it already kind of looks like something that you don't expect. So the first thing you're gonna try is take a big handful and squeeze it really tight in your palm. This chunky mixture that becomes a solid when I'm pressing it, almost like it's a ball of clay, but the second I stop putting pressure on it, it turns right back into a liquid. So the second thing I'm gonna show you guys is what happens when I rest my fingers on the top of it. So when I put my fingers on the top, they go straight to the bottom and go straight to the bottom of the mixture. But if I put my fingers on it very fast, like this, I can't, it's like a full hard surface. It feels like I'm tapping like a solid white marble surface. But if I touch my finger slowly, that's what happens. See, fast, my finger doesn't go in. It bounces off the top as if I'm tapping, you know, a hard surface. But then I go slowly and my finger sinks right in. So check this out. You see how it's so, like, it cracks at the surface like it's a paste, but then becomes a liquid again very quickly. And you can pinch it open and see that it's like sort of a powder. And I'm holding this, but then watch, it just melts away. So the third thing I'm gonna show you guys how to do is take a big amount of this goo. It's kind of hard to get out because it just keeps becoming hard when I put pressure on it. And I'm going to roll it into a ball. You can see that it's very easily becoming a ball when I press it. And it feels like I'm squeezing it so hard that it becomes cracked in the center, like it's a solid or something. But then when I take this ball and I just let it lay in the palm of my hands, it melts like an ice cream cone. So it's a hard ball that I'm, you know, tapping, and it's like it fully feels like a solid. Oh, crumbled it. It was so solid. And then when it's not having pressure applied to it, we see what happens. So what I would recommend for you guys to do is get this mixture set up and just experiment with it to your heart's content, because I think this is one of the most interesting and also confusing phenomenon. So it's very cool. All right, y'all. So after all that confusing experimentation with cornstarch and water, it's time to explore what actually happened in this mixture to make it such a weird, half liquid, half solid ooze that was so fun to play with. So your cornstarch ooze is made up of tiny solid particles of cornstarch suspended in water, meaning they're just kind of flowing around in the water freely in the bowl that I put it in. And when I bang on it really quickly, or try to squeeze a handful of the ooze, it freezes in place and acts like a solid. The harder I push, the thicker the ooze becomes. But when you open your hand and apply no pressure to it from your hand, the ooze drips like a liquid. So what happens here is your finger, when you put pressure on it, is actually applying what a physicist would call a sideways shearing force to the water. So in response to that force, the water shears, meaning it moves out of the way. And the behavior of the ooze is actually related to a thing called viscosity. So the viscosity of a substance, whether it be cornstarch in water or water itself or orange juice or yogurt, it just means its resistance to flow. So like you can think of viscosity as, you know, how fast it would flow off your hand. So like if you put a bunch of water on your hand, it's gonna flow off really fast. If you put a bunch of yogurt on your hand, it's kind of like, you know, slowly dripple down because it's a bit thicker. So viscosity is like the resistance to flow. So the yogurt is more viscous than the water. So this cornstarch mixture actually has different properties of viscosity depending on how hard you're pushing. So water's viscosity doesn't change when you apply a shearing force, but the ooze does. So when you're applying the force to it, it is very, very viscous, meaning resisting the flow. So it is almost like a solid because of this shearing force. Without pressure, meaning when it's just falling off of your hand, or when you stick your finger in it very slowly with no push, just letting it sink in, that's when it becomes less viscous and behaves more like a liquid than a solid. So these properties of solids and liquids are very vaguely understood, but it's still super fun to play with and kind of makes you think about what's going on at the teeny tiny level in this mixture to make it become a half solid, half liquid, depending on how you touch it. All right, y'all, so that was cornstarch and water ooze. I hope you guys enjoyed. So I hope y'all have a good time trying this out on your own or just following along the video and maybe doing some YouTube searches for other cool cornstarch and water videos. This stuff is awesome. You can put food coloring in it too to make it like a, you know, a fun, or like glitter or anything to make it like almost like a slime, but kind of like half slime, half solid. So it's really cool. The possibilities are virtually endless. So thanks y'all for watching and I hope you enjoyed. Bye! Hey y'all, it's Rolly. Welcome back to the science program broadcast. In this video we're going to be doing something super cool. A fun and very foamy and messy experiment called elephant toothpaste. If you guys have seen this before, that's great. If you haven't, the reason it's called elephant toothpaste is because out of this bottle will flow a bunch of foam that looks like it's toothpaste made for an elephant. So what I have to use today are a couple rubber gloves just to protect my hands during the experiment and so I don't get food coloring all over them. Some liquid dish soap, warm water, just got this, you know, from the hot setting on my faucet on the tap. I have my glasses just to protect my eyes during the experiment. Some measuring tools. I have a tablespoon and a half cup. Hydrogen peroxide, 3%. Some dry yeast, the same stuff you would use to make bread. Some food coloring, whatever colors you want. I just got an assorted pack. And some empty plastic bottles. I just picked them out of my recycling bin. But you can really use anything that is tough enough that it would, you know, not break and has a nice curve at the top so that it comes out looking like toothpaste. Okay, so the first thing I'm gonna do is talk about safety. So hydrogen peroxide is actually used as an antiseptic, which means it's safe for your skin, but it can be irritating to your eyes. So if you do get it on your hands, make sure not to rub your eyes. And a safety measure that I'm gonna take is I'm gonna put my glasses on. If you have goggles, swimming goggles, lab goggles if you have them, or glasses, sunglasses, anything like that, just so any splash will hit the glass and not get in my eye. I'm also going to be putting on these gloves, these disposable gloves, in order to protect my hands from the chemicals and just make it a bit easier not to get food dye staining my hands. But if you don't have gloves, it's okay because everything that we're using today is safe for the skin. That being said, we are using chemicals for this experiment, so if you do decide to try this at home, please make sure you have your guardian around to help you with measuring it out and make sure everything is safe. I'm going to use this big plastic bin in order to have the experiment contained in the bin so that the foam doesn't get anywhere and it's easy for cleanup later. But if you do this in your backyard and you don't have a bin, that's fine. It will come off when it rains and all that stuff, and none of these chemicals are harmful to the ground, so you're okay with that. So the first thing I'm going to do is I'm going to line up my plastic bottles in the bin. So the next step is I'm going to be measuring out 3/4 of a cup of hydrogen peroxide and putting it in each of the bottles. So the next step is I'm going to take my liquid dish soap and just put a good squirt in each. The next thing I'm going to do is color it with my food coloring. So I have 4 colors, 4 bottles, so you can kind of guess what's going to happen here. And I'm going to put a few drops in each. So this is what they look like with the hydrogen peroxide, food coloring, and soap in them. So now what I'm going to do is mix 1.5 tablespoons of dry yeast, which I have in these packets, with about 4 or 5 tablespoons of warm water. And I'm gonna do that off camera. All right, guys, so it's the moment you've been waiting for. I have my friend Tofu here to help me because I don't have that many hands. So what we're gonna do is we're gonna take the little cups with the yeast mixture that we just made with yeast and water, and simultaneously we're gonna try and pour them into the bottles and just jump back as fast as we can to see the reaction, okay? 1, 2, 3. So there you guys have it. These bottles are still kind of producing foam. They've been going for about a minute and a half now. Really cool, really pastel-y colors. And now let's dive into the explanation of the reaction. So what happened in these bottles that created this massive amount of colorful foam? So what did we put in there? We put in hydrogen peroxide. Hydrogen peroxide is made out of the elements hydrogen and oxygen. So as soon as you put the yeast in there, it creates a chemical reaction that will break down the hydrogen peroxide. The chemical reaction that is produced with the yeast and the hydrogen peroxide combining actually produces 2 new substances that weren't there before. The hydrogen peroxide, which has hydrogen and oxygen, is broken down into water, H2O, and oxygen gas, O2. So the oxygen gas is in its gas form, which means it really wants to get out of the container and be free in the atmosphere because it's really high energy and it wants to get out of the bottle. So that's what we see when it's coming out of the bottle really fast and in like a very foamy explosion. But what happens is that the oxygen gas actually gets trapped into the dish soap we put in there. And the dish soap allows the oxygen gas to kind of dissolve into it and produce a foam rather than just gas escaping the bottle. If we didn't have the dish soap in there, it would just be a bunch of bubbles, but the bubbles are trapped in the soap, making it like a nice, fluffy foam that we see here. All right, now it's time for me to clean this up. So what I'm gonna do with all this foam that is in my bottles and also collected in my bucket is I'm just gonna put it down, rinse it out in the sink because everything we use today is actually safe for the sink. If there's big chunks of yeast in there, make sure you're picking those out and throwing them in the trash so they don't clog your drain, but it should be pretty much dissolved and safe to just go right down the drain. All right, guys, so that was elephant toothpaste. As you can see, it looks like toothpaste fit for an elephant, but remember, it's not real toothpaste and not safe to use. Thanks y'all for watching. Bye. It's Rolly, and in this video I'm going to be showing you guys how you can make your very own DIY do-it-yourself lava lamp out of just olive oil, water, some food coloring, and a little bit of effervescent medicine, which I will explain in a minute, I promise. It's a really simple and easy experiment that's really fun to show your friends or family, or just have a little bit of fun decoration in the corner of your room, a little fun little lava lamp going. So keep tuned to see how we're gonna make that. So for materials, I have an empty plastic bottle. You can use a bottle from your kitchen or from your recycling bin. I took this one out of my recycling bin. Some vegetable oil, any vegetable oil works. Some water, doesn't matter what temperature. Alka-Seltzer, which is a effervescent medicine. Basically all that means is when you drop it in water, it's gonna start bubbling up. And food coloring. Okay, so the first step in this experiment is to take your empty bottle and fill it most of the way with vegetable oil. So now that my bottle is filled with vegetable oil, I'm gonna take my water and fill the rest of the bottle with the water. And you can see that the water and the oil don't mix. So the water is actually in little bubbles at the bottom of the bottle. I'm gonna choose one color. I'm feeling a little bit green today, so we're gonna do a green lava lamp. I'm gonna add just maybe like 5 or 6 drops of this. And what you'll notice is that the food coloring is water-based, so it actually goes to the bottom of the bottle where the water is. So when the oil and the water separate, the food coloring separates with the water. All right, now we're ready to basically get this thing moving. How we get the active, flow of a lava lamp is we're gonna take a piece of Alka-Seltzer, and I'm gonna take this tablet and I put it right in. My lava lamp is going to keep fizzing and doing the lava activity until the Alka-Seltzer tablet is entirely dissolved, which is what you see has happened here. If you wanted to keep it going, all you have to do is just add another piece of Alka-Seltzer, and you can keep this around. If you keep the bottle cap, you can put it right back on and keep it somewhere in your room, and whenever you want to see the lava lamp do its thing, just drop a tablet in there and watch it bubble up for around a couple minutes and have a cool decoration in your room. Now let's talk about the science of what happened in the lava lamp to create this cool visual bubbly experience. So a lava lamp works because of 2 different scientific principles: density and polarity. Density is the measurement of how compact a substance is and how much of it fits in a certain space. So, this would be a not very dense hand because it's spread out, and this would be a denser hand because it's more hand in a smaller space. So if you measure an equal volume of water and oil, so you have, a cup of water and a cup of oil, you'll find that the water is actually heavier than the same amount of oil, even if it's the same volume, like the same amount of cup filled. So because the water is actually more dense than the oil, it will sink to the bottom when the 2 are put into the same container. So water molecules are polar because they have a lopsided electrical charge that attracts other atoms. So if another atom had a charge, water would attract it. Just like in a magnet where the 2 opposite ends attract and then the other sides will repel each other. It's the same concept in a magnet that will explain the polarity in water. Vegetable oil, or any oil for that matter, is nonpolar, which means they don't have a positive or negative charge, and they won't attract molecules that have charge. So the oil molecules are not attracted to the water at all. In fact, they repel them. So the oil molecules will clump together and the water molecules will clump together. And this is why oil and water don't mix. when we add the Alka-Seltzer, which is a fizzing agent, and it just, you know, gets in the water and starts fizzing, it creates like motion in this mixture, but the water and the oil still won't mix. So what we end up seeing is bubbles of the water rising to the top and then going back to the bottom, and rising to the top and going back to the bottom. It creates this lava lamp action by moving around two liquids that are together in the same bottle but can't mix. And the reason we can get the lava to look like color is because the food coloring is mixed in with the water, and therefore it will rise up and rise down with the water, creating this like lava bulge sensation that we see. I can do another one since it's settled down. I can see what I mean directly. So you're seeing the balls of water and food coloring that is mixed moving through the oil, but it won't mix with the oil. And that's why it looks like a lava lamp. Pretty cool, right? All right, y'all, so there you have it. DIY lava lamp. I hope you guys enjoyed watching this, and I hope you guys get a chance to try this out yourself. Have a great time, and thanks for watching. Bye.